So this is going to look at a few examples of proportionality, which is presented with power functions. So we have two types of proportionality that we'll look at, relationship between variables. One is called direct proportionality, or being directly proportional, and the other is called inversely proportional, or having an inverse relationship. So we'll start with the directly proportional. Excuse me. So the way that directly proportional works is the variables do the same thing. So if one increases, the other one increases. If one decreases, the other one decreases. They have that matching relationship. And you'll see it written in the phrase, y is directly proportional to x. And when you see that, you need to be able to translate it to this equation where whatever it starts with, the y is directly proportional to. Anytime something is directly proportional to something, you're going to multiply this constant called the constant of proportionality. And if it's a directly proportional, it will directly multiply by whatever it tells you to. So for example, if you have the phrase y is directly proportional to x to the n, like the power functions that we've been working with, then that would translate to the equation y equals the constant directly times x to the n, like whatever it said it was directly proportional to. So y equals k times x to the n. If you have an example where it says y is directly proportional to the cube of x, cube being an exponent of 3, then that's what you'll set up in your equation. Y is a constant directly multiplied by the cube of x. Same thing for this last example. Y is directly proportional to the square root of x. So you'll have y equals a constant times the square root of x. So your job to begin with, or actually mainly, will be to take these verbal sentences that is describing the relationship of direct proportionality and translate them into these equations for which you're going to be given the x and the y values, or whatever variable they choose to use for input and output, and then you'll have to use those values and solve for k, and then you'll be able to use that to predict other equations. So here's an example on using the direct proportionality. So say you had excuse me, c is directly proportional to the square of d. So what that would look like as an equation, c is directly multiplied in proportionality to the square, which is an exponent of 2, of the variable d. So you have the setup for your directly proportional relationship. Then it goes and gives you a c value of 45, and then it also gives you a d value of 3. So it's explaining the variables and the relationship here. So you plug those in. Plug 45 equals k times 3 squared. Following order of operations, we'll square the 3. Again, we're trying to solve here for k, which again is called the constant of proportionality. So we get 45 equals k times 9. And then if we divide both sides by 9, we get that k is 5. So we have our constant of proportionality is 5. Excuse me. So now we can use that to go back to our directly proportional relationship equation, and we get that c equals 5 times d squared. So if the question, had you find the formula, which is what we found, that's our formula that shows our relationship, then you could use that formula. So use your formula to find c when d equals 5. We have all the things that we need to take and substitute in what it wants us to find. So when d equals 5, we'll just take c equals 5 times the value of 5 squared. Please remember order of operations here. This is not really the greatest example because everything is 5s, but you need to do exponents first. So we'll do 5 times 20, we'll do this 5 squared, which is 25, and then when you do 5 times 25, you get 125. So you have to be able to set up the equation, you have to be able to solve for the constant of proportionality, be able to plug it back into the formula for an answer, and then you may have to use that formula to find given values. Okay, so here we'll do another example of the direct one. So say you have y is directly proportional to x, and you're given that y is 6 when x equals 4. So find the constant of proportionality. Find the constant of proportionality and write a formula for y in terms of x. Okay, so we'll start with that. So y is directly proportional to x translates into y is directly as a constant times x. And then we're told y is 6 when x is 4, so we can plug those in. So y is 6, x is 4. We'll divide both sides by 4, and we'll get that k is the constant of 3/2, or 1.5. I'm just going to leave it 3/2 for the sake of being exact. So the equation is y equals 3/2 x. Okay, so that's our formula for y in terms of x. And then you could use the formula that you found to find x when y equals 8. So you look at what they give you. So we have the formula y equals 3/2 x, but now it wants us to find x, and it's giving us the y value. So make sure you plug in accordingly. So we have 8 equals 3/2 x, and we need to solve for x. So I'm just going to, since it's multiplied by a fraction, you could divide by 3/2, but I'm just going to multiply by the reciprocal times 2/3. And you get that x is 16/3, which will be a repeating decimal, so this is an exact answer. It doesn't simplify, of 16/3. So again, directly proportional, find the equation, find the constant, give your equation with the constant filled in, and then you may have to use your formula to find values that relate to it. So that's directly proportional. The other one in this section is called inverse proportion. So it's going to be the opposite. An inverse relationship, whenever one value increases, the other one decreases and does the opposite. So when you see the phrase y is inversely proportional to x, you'll still have y equals an equation, and you'll still have that constant of proportionality. But anytime you see inversely proportional, then that constant is going to get divided by whatever it's inversely proportional to. So like, for example, if it says y is inversely proportional to your power function x to the n, that would translate to y equals constant divided by x to the n. Or if it said y is inversely proportional to the cube root of s, just to throw in a different variable, then your equation would be y equals k divided by cube root of s. Okay, and then most likely it would give you the input and the output, and you'd have to plug them in and find your constant. That's where this is headed. Okay, so we'll do a few examples of those, but the difference here is it's a division by whatever it's inversely proportional to, and you have to make sure that you put that constant in the equation whenever you go to set it up. So I will, add another page and show you a few examples. So here's one. It says, suppose C is inversely proportional to the square of D. And it says if C equals 45 when D equals 3, they want you to find the constant of proportionality, the K value, and also write the formula just like before. So we'll write the formula for C as a function of D. Okay, so we'll start with setting up the equation. Suppose C is inversely proportional to the square of D. So what that's going to look like is C is inversely, takes the constant and divides it by the square of D. And then we'll use the values that it's told us to plug in. C is 45 when D is 3. So you take those values and you plug them in. 45 equals K over 3 squared. Maintain order of operation usage, and you'll get K over 9, and then multiply both sides by 9 to solve for K, and you get that K is a nice 405, okay? So putting that back into our equation gives us our formula for C in terms of D as C equals 405 over D squared, whatever that relationship would be. So then, once you found that, it might ask you to use your formula. So use your formula to find C when, in this example, we'll do when D equals 5. So you've got your C equals 405 over D squared. You plug in the numbers that they've given you, which is D equals 5, so that goes in the denominator. And you get C equals 405 over 5 squared. Again, please follow order of operations and do exponents before you do division. So that'll be 405 over 25, which will be 16.2 if it's a decimal, which I realize is 16 1/5. And if you ended up doing that as the fraction, it would be 81 over 5. So I realize that 16.2 is a terminating decimal, but the 81 over 5 is going to be the exact fraction answer. But numerically, they're all the same. It just depends on what format you have to input it for the online homework software, of course. Let's do another example of an inverse relationship. So say you have a setup that says y is inversely proportional to x, and you're told that y equals 6 when x equals 4, and same setup. Find the constant of proportionality and write a formula. And this time it'll be write a formula for y in terms of x. So y is a function of x. And then we'll use it to predict. So we'll start with y is inversely proportional to x. That will be y is a constant divided by x. Again, inverse proportion takes the constant and divides it by whatever it's inversely proportional to. And you're told when y is 6, x equals 4. So let's plug those in. When y equals 6, x equals 4. And now we're solved for k. In this case, 4 is being divided, so we'll do the opposite and multiply. So we get our k value is 24. So that will make our formula y equals 24 over x. And for this example, let's find x when y equals 8. So we'll take the formula that we found, our 24 over x, plug in what we're given. This time we're given y. So that'll be 8 equals 24 over x. So you can go through and be like, oh, 24 divided by what is x? But if you're not that great at that, do the algebra, times both sides by x, and you get 8x equals 24, then divide both sides by 8, and you'll get that that value is in fact 3. So directly proportional or inversely proportional, one is a direct multiplication, one is an inverse division. You have to set the equation up. You have to find that constant of proportionality. Give the formula with the constant plugged back in, and then you'll use your new formula to predict values. Sometimes you'll find the input, sometimes you'll find the output, but those are the setup directions for those proportional relationships.